Right, we have finished 13.3. Now we are going to 13.4. Capacitors in series and in parallel. We are required to derive and use a formula for effective capacitance of capacitors in series and parallel. Okay, let's do that. Sorry, some technical problem.
Yep, I'm waiting, sir.
Okay, let me just record it down. Okay, capacitor in series and in parallel. Basically, these are the two formulas that we will be looking at. Right, it's parallel, you add the capacitance. In series, you take the reciprocal. As I say, it's opposite to resistor. Okay, we are going to use this idea that you have studied, right? Two uncharged conductor touching each other. We bring a negative charge balloon. So we basically induce a positive charge here. Or we
Just start again, sir.
when we bring a charged balloon, negatively charged,
Okay.
right? It will induce a positive charge there. That's your STPM work. Or it will repel the electron to the other side, far away. It's the electron that is mobile, that is free to move. Positive charge cannot move. So you repel the free electron to the other end. Then you separate them, you have a separate charge as well. So we are just using this idea. You bring a negative charge, it will induce a positive charge here. Or the electron are repelled to go further away. Okay, capacitor in series, you got capacitor C1, C2, C3. That is your battery. V across C1 is V1, across C2 is V2, across C3 is V3. Electron move from the negative terminal of the cell to the plate. This is the negative terminal. Right? Electrons will move from here to the X plate. So the X plate becomes negative. So basically, it will induce a positive charge on the Y plate. So the electron will be repelled to the Z plate. So Z plate now becomes negative. So it will induce a positive charge on the other side. Right? So it just carry on, that's all, until the electron is finally returned to the positive terminal. Right? Remember, electron doesn't flow through the medium, but it just repels. Okay? It looks like there's a current flowing also. Okay with that?
Okay.
So what we want to do is we want to replace that 3 resistor with 1, called the equivalent capacitor. So the charge here, the charge on the right hand plate will be negative Q. Right? So it's negative Q, it repels the same amount of electron, so it becomes positive Q. Right? Magnitude is the same. Conservation of charge, it cannot increase. This is minus Q, this is plus Q. This side to the right is minus Q. The left hand plate is plus Q. Same here. Right hand side, right hand plate is minus Q. Left hand plate is plus Q. Okay, that's what we say here. Right plate of each capacitor carries a net negative charge minus Q. Conservation of charge, left hand plate, which is this one. Right? In this case, is Y, is plus Q. So instead of working
So go back again.
Okay.
Okay. Sure. So that means the main idea means the electron won't flow to the capacitor, it will just repel only to the capacitor,
Just repel.
right?
or you induce a positive charge, then the electron will move to the Z plate.
Okay.
Different from current in conductor. So instead of having 3 capacitor, we want to work with 1 called equivalent capacitor. And then we use the same battery. Right? The charge on each of these plate is the same as the charge stored on this equivalent capacitor. Right? The charge on the right hand plate is the same. Equivalent capacitor stores the same charge. That's what we just say. Right? If it's Q here, it is also Q here. Right? PD is still the same, doesn't change. Okay, minus Q plus Q, same. The charge is the same.
Go back again, sir. So they're trying to tell it's the same only, like everything is the same.
Charge is the same.
Right, sir?
Not, why should it be different? We are just representing the 3 of them with 1, that's all. So same battery we are using. So the charge stored there must still be stored here. That's the idea.
Okay.
Right? So different book will call it different name. Your syllabus call it effective rather than combined or resultant or total. Right? I call it CR or resultant. So it's just reciprocal. So next part we are going to derive it. Right? So if it's 2 capacitor, rather than use this formula, you can still do the same thing. Right? You multiply the 2 of them and then you add the 2 of them there. That's all. Faster lah, rather than, not that I cannot use, it's just faster to use this formula, especially you solve objective question. So how to derive it? Same thing, right? We use Kirchhoff's voltage law, which is our next, which is we'll study in for 15. Kirchhoff's voltage law, we just add the voltage as well. This is the total, and these 3 add together must equal to the V. Okay, V at V equals to V1 plus V2 plus V3. Then we are just using V equals to, or Q equals CV. We are just using the formula. Instead of V, we want the charge. Charge divided by your capacitance is your V1. Want to replace V1 with Q over C. So for each of them, for this one, it's just charge divided by CR. For this one, it's just your charge divided by C1, charge divided by C2, charge divided by C3. Then we just cancel our Q, all become 1. Then we get this formula. We get this formula. Okay, very straightforward. Happy with that?
The donkey part only, sir.
What's the problem? I'm just replacing the voltage
No,
there. Replace each of the
for
voltage there.
2 capacitor C1 times C2 over C1 plus C2.
You just cover this one up.
Mm-hmm.
Common.
Okay. Got it. Okay.
Don't tell me SPM, your teacher didn't teach you all that.
Sir, isn't it supposed? Yeah. Okay. Yeah. Got it. Yeah. Sir, my bad. Sir. Okay, can continue.
Okay. So always remember your CR is always smaller than any of these capacitance. When you take it in series, it's always smaller than C1 or C2 or C3. And this one don't need to worry. This one, if you want, you can just put numbers there. So if you got n of them, each of them with capacitance C, that's what it means. With this one, the equivalent capacitance become smaller, C divided by N. Okay with that? Just memorize only, nothing much. Or you want, you can derive from here. C, 3C. Invert it is C. If it's 3 of them, it's C divided by 3. Can.
Can. Oh, that means what they're trying to tell means go back again. That means like more capacitor mean effective will decrease. If effective increase when there's only less
If you put
capacitance,
more
right?
capacitance there, your C becomes smaller. That's all.
Yep,
Your
correct.
effective one becomes smaller. And it's always smaller than the smallest one.
Yeah.
Okay, try this question.
Okay.
Just using the formula only, that's all. Can?
Can.
No need to convert.
I got the answer.
No need to convert. Whatever unit you use, you get a unit back. Then how to calculate the PD across C1?
Q equals to CV.
That's all.
Yeah, so total is
find
0.055 divide 12. Why times 12? Sure, they want PD teacher, not Q. What?
You have to find Q first, right? You know how to count your,
Oh,
isn't it?
yes.
You have to find your Q first. Q in the resultant capacitor. Then after that, you work with your, find your V1.
Oh, separate. Okay.
Then find your Q first from the resultant. Okay with that?
Okay.
Let's go to parallel. This is parallel. Same thing. Current come out, branch into I1, I2, I3. This is the source. I is the source of the battery. So instead of thinking of it as I, we think of it as Q. Q is flowing out from the battery. Right? And then you branch to C, Q1, Q2, Q3. Right? Because the capacitor is the one that decides what is the charge stored on it when the PD is the same. What charge will be stored here will be Q1, and the charge stored here will be Q2, charge stored here will be Q3. Right? It's a capacitance that determines how much Q1 will be. C2 will decide how large Q2 will be. Right? From this formula, Q equals CV. Right? So we are just using this formula again. So we can redraw that. Instead of having 3 in parallel, we replace the 3 with 1. The battery is still the same. V is still the same. Right? But remember the charge here is different. It's C3, Q3, Q2, Q1. Right? So the 3 capacitors can be replaced by an equivalent one. Right? Store the same total charge, right? Same battery. So instead of storing Q1 or Q2 or Q3, store all of them add together. Q here. Right? So that is your Q. Q branching out to Q1, Q2, Q3. So that is a charge from that one coming from the battery. So on the left hand plate, this side, left hand plate, here will be plus Q, and the other side will be minus Q. Right? So that charge there equals to Q1 plus Q2 plus Q3 because that is your source. Q is your source. And the thing to know when it's parallel, the PD across each capacitor is the same. Okay with that? That's the first point you have to know. The potential difference across each capacitor is the same. That's when we know it's parallel. That's how we know it's parallel. Okay, no?
Okay.
Derivation. Right? We're just using Q equal to Q1 plus
Teacher,
Q.
go back again. Just give me 1 minute, sir.
It's in your book. So in your book.
Oh, that means they are just trying to tell they can sample lah, sir. That means.
It's just this is a battery that provides this charge. So this charge must be all these three add together, and this total charge must appear on this plate there. That's all. Where is this called the equivalent capacitance? Okay.
Yeah. Okay. Yeah. Potential difference will be the same.
So we are just using the basic formula. The charge on this plate Q is just Q1 plus Q2 plus Q3. Right? Then we want to express in terms of C, we use Q equals CV. That one. Right? So apply for this plate there equals to CP plus CP times V. Right? CP times V. Applying to this plate is C1 times V. That one. Apply to this plate C2 times your V. V is the same. C2 times your V. Apply to this plate is C3 times your V. Right? So V and all the V cancel off, common factor. Cancel all the V. So you get the answer already. Very straightforward, this one. Or divide by V, get the answer. The equivalent capacitance, you just add all them up. Can?
Can.
So if it's n of them, each of capacitance C, then you just n times C. Okay. Try this one.
Yeah, go over again. Okay.
This one. Try this one. Yeah, just using the straightforward, using the formula, that's all.
Yeah, 1 minute. Yeah, 0.6.
That's all. Then charge store in C1.
Wait, let me try this. Q equals to CV. So 0.6 divide 12. Oh.
Okay.
Oh, okay.
You work with the resultant. So the charge on the resultant is the one we are looking at. So that is your resultant. Okay, what have I done? Oh, I done something here. Sorry.
Okay.
I have done something wrong. Sorry. We have done something wrong.
Charge stored in total C or what? Or only C1?
C1. Correct.
Correct lah.
I just take the capacitance times the potential difference across it. Okay, try the next one. A bit harder now. Yeah, how to solve?
Just give me a minute, sir.
Same like your resistance, nothing different.
Yeah, just 1 minute, sir. The answer is 53.88.
Okay, 24, wrong.
Oh, okay.
You work with step 1. Replace this one first. Yeah. Replace this one that you can see clearly is parallel. Replace this one with that one.
Uh-huh.
So that one becomes C. That one becomes C. Replace this one C. And then this 40 is still there. So this is parallel. You add them up, lor. Yeah, add them up.
Yeah.
23 plus 35. Then now we have
58.
found C. Use the reciprocal. Step 2. Replace the series. Now is series. Just now you replace that parallel. Now you replace that series. The effective one is 1 over C1 plus 1 over C2. 50. No need to convert. Whatever unit you use, you get the same unit back. And take the reciprocal.
Yeah. Oh, Che, do you know what I did, Che?
Yeah.
Che? What I did actually was, to be honest, I did opposite, you know, Che. I did 1 over 23 plus 1 over 35. I find the CR and then I plus 40.
This is not resistance. This is capacitance. Right? When
Oh,
it's
yeah.
parallel,
Okay.
you add. When it's series, you take the reciprocal.
Yeah.
So anything else you want to ask? So I expect you to do 13.4. Series and
13.4.
parallel. There's a lot of it for you to
Okay.
try. So Saturday, 9 to 11. I expect you to have done that.
Yes. Okay, Che.
So Saturday we should finish already. The question you can
Hey,
ask.
Che, how about Friday, Che? Like 1 hour, 1 hour.
Friday, what time you want?
4 to 5.
Friday, 4 to 5. Okay.
I will confirm to you by tomorrow, Che.
Okay. Okay. But you need to do the work
Okay.
first.
Yes, Che.
Okay.
Okay.
Have a good day. You stop here.
Good day, teacher. Okay. Bye bye.
Bye bye.